Our solar system is vast, a cosmic expanse filled with wonders and mysteries waiting to be explored. It's filled with planets and moons, each with its own unique characteristics and potential for discovery, but only one stands out as a possible second home for humans: Mars. This red planet has captured our imagination for centuries. Why Mars? It's the most similar to Earth in many ways. From its day length to its seasonal cycles, Mars mirrors our home planet in fascinating ways. A day on Mars is almost like an Earth day, lasting just over 24 hours. This similarity makes it easier for humans to adapt to life on Mars. Mars has seasons, just like Earth. These seasonal changes are caused by the tilt of Mars' axis, similar to how Earth's seasons are created. We also see evidence of ancient rivers and oceans on Mars. These dried-up riverbeds and lake beds suggest that liquid water once flowed on the Martian surface. This tells us Mars was once a warmer, wetter place, potentially capable of supporting life. Understanding Mars's past climate helps us learn more about the planet's potential for future habitability. Mars has lots of frozen water. This water is found in the form of ice, both on the surface and beneath it. It's trapped beneath the surface and in the polar ice caps. These ice deposits could be crucial for sustaining human life on Mars. Water is essential for life as we know it. It is a key resource for drinking, growing food, and even generating oxygen. This makes Mars a prime candidate for terraforming. Scientists are exploring ways to transform Mars' environment to make it more Earth-like. Terraforming means transforming a planet to make it more like Earth. It's a big dream, but one that could open up new possibilities for human civilization. But with enough time and technology, it might be possible. Advances in space travel, robotics, and environmental engineering are bringing us closer to making this dream a reality. Human exploration missions to Mars are already in the planning stages. These missions will pave the way for future colonization efforts. Imagine living in habitats on Mars, growing food in Martian soil, and exploring the vast landscapes of this intriguing planet. The future of Mars exploration holds endless possibilities. As we look to the stars, Mars stands out as a beacon of hope and adventure. The journey to Mars is not just about exploring a new world, it's about pushing the boundaries of human potential and imagination. Mars right now is not a friendly place for humans. The air is thin, there's no liquid water, and it's very cold. The surface is barren, and the atmosphere is not suitable for human life. The conditions are harsh, and survival would be nearly impossible without significant changes. The planet's environment is hostile, and we need to address several critical issues to make it habitable. To live on Mars, we need to make some big changes. Establishing a human presence on Mars requires transforming the planet into a place where humans can live and thrive. This involves creating sustainable habitats, ensuring a stable supply of resources, and developing technologies to support human life. The vision of a futuristic Mars colony is ambitious, but it is achievable with the right advancements and innovations. First, we need to warm up the planet. Mars is currently too cold for human habitation. The average temperature on Mars is far below freezing, making it inhospitable for humans. To create a more Earth-like environment, we need to find ways to increase the temperature on Mars. This could involve large-scale projects to release greenhouse gases or other methods to trap heat and warm the planet. The average temperature on Mars is far below freezing. In fact, it can drop to as low as -80 degrees Fahrenheit, which is much colder than any place on Earth. Such extreme cold poses a significant challenge for human survival. We need to develop technologies and strategies to raise the temperature and create a more hospitable climate. No human could survive that for long. Even with advanced spacesuits and survival gear, the extreme cold would make it difficult for humans to live and work on Mars. Prolonged exposure to such low temperatures could lead to severe health issues and make it impossible to sustain a human presence on the planet. Next, we need to give Mars a thicker atmosphere. The current atmosphere on Mars is too thin to support human life. A thicker atmosphere would help retain heat, making the planet warmer and more suitable for human habitation. It would also provide some protection from harmful solar radiation and help create a more stable environment. The air on Mars is mostly carbon dioxide, which humans can't breathe. To create a breathable atmosphere, we need to find ways to produce oxygen and reduce the levels of carbon dioxide. This could involve using plants, algae, or advanced chemical processes to generate oxygen and create a more Earth-like atmosphere. A thicker atmosphere would also help trap heat and raise the temperature. We also need oxygen. Without a sufficient supply of oxygen, humans would not be able to survive on Mars. Developing technologies to produce and maintain a stable supply of oxygen is crucial for creating a habitable environment on the planet. Humans need oxygen to breathe. On Earth, we take this for granted, but on Mars, it is a significant challenge. We need to develop systems to produce and store oxygen, ensuring that there is always a sufficient supply for human needs. This is essential for both short-term missions and long-term colonization efforts. Creating a breathable atmosphere on Mars is a huge challenge. It requires advanced technologies and innovative solutions. Engineers and scientists are working on various projects to address these challenges, from developing new materials to designing efficient life support systems. The goal is to create a self-sustaining environment where humans can live and thrive. Finally, we need to protect ourselves from radiation. Mars doesn't have a strong magnetic field like Earth's, which means more harmful radiation from the sun reaches the surface. This radiation can pose serious health risks to humans, including increased chances of cancer and other illnesses. Mars doesn't have a strong magnetic field like Earth's. The weak magnetic field on Mars provides little protection from solar and cosmic radiation. To ensure the safety of humans on Mars, we need to develop effective radiation shielding technologies. This could involve building habitats with thick walls, using advanced materials, or creating underground shelters. This means more harmful radiation from the sun reaches the surface. Without adequate protection, humans on Mars would be exposed to dangerous levels of radiation. Developing effective shielding and protective measures is essential for ensuring the health and safety of future Mars inhabitants. By addressing these challenges, we can transform Mars into a place where humans can live and thrive. So, how do we warm up an entire planet? It sounds impossible, but scientists have some ideas. One idea is to use giant mirrors in space. These mirrors would be enormous, bigger than any satellite we've ever built. They would reflect sunlight onto Mars, warming specific areas. Imagine focusing sunlight on the polar ice caps, releasing trapped carbon dioxide. Another idea is to release greenhouse gases into the Martian atmosphere. Greenhouse gases trap heat, which would slowly warm the planet. We could find these gases on Mars, or bring them from Earth. These are just two ideas. Terraforming a planet is such a huge task. We'll likely need many different approaches working together to make it happen. A thicker atmosphere is crucial for making Mars more Earth-like. But how do we get more air on a planet that's lost most of its own? One radical idea involves asteroids. We could carefully redirect asteroids containing ammonia and other gases to crash into Mars. This would release those gases into the atmosphere, thickening it over time. Another idea is to build factories on Mars. These factories would be designed to pump out greenhouse gases. It's like mimicking Earth's industrial revolution, but on a planetary scale. We could also try to awaken dormant volcanoes on Mars. Volcanoes release gases from deep inside the planet. If we could trigger them safely, it could help thicken the Martian atmosphere. Section 5, breathing easy. A thick atmosphere is great, but we also need oxygen to breathe. This is where things get really tricky. One solution lies in the power of nature plants. Plants take in carbon dioxide and release oxygen. It's how they survive. We could use this process to our advantage on Mars. Imagine vast fields of specially engineered plants covering the Martian surface. As they grow, they slowly transform the atmosphere, making it breathable for humans. Another option is to build machines that do the work of plants. These machines would suck in carbon dioxide from the atmosphere and split it apart, releasing oxygen. Section 6. The radiation problem. Radiation is a silent killer, an invisible threat that poses significant challenges for human exploration and settlement on Mars. Radiation is a silent killer. It can cause severe health issues, including cancer, radiation sickness, and damage to vital organs. Prolonged exposure can be fatal. Without a magnetic field like Earth's, Mars is bombarded by harmful radiation from space. Cosmic rays and solar particles penetrate the thin Martian atmosphere, making the surface a hazardous place for humans. We need a way to protect ourselves. Scientists and engineers are working tirelessly to develop innovative solutions to shield future Martian settlers from this invisible menace. One idea is to live underground. By building habitats beneath the Martian surface, we can use the planet's own soil and rock as a natural barrier against radiation. Building our habitats beneath the surface would shield us from most radiation. This approach leverages the natural protection offered by the Martian terrain, creating a safer environment for long-term habitation. We could even use natural caves and lava tubes for shelter. These geological formations, already present on Mars, could be adapted into living spaces, providing ready-made protection from radiation. Another, more ambitious idea is to create an artificial magnetic field around Mars. This concept involves generating a magnetic shield that could deflect harmful radiation, much like Earth's magnetic field does. This would deflect radiation just like Earth's magnetic field does. While this idea is still in the theoretical stage, it represents a bold step towards making Mars a safer place for human life. It's a huge technological challenge, but it might be possible one day. Advances in space technology and engineering could bring this vision closer to reality. We could also develop special materials that block radiation. These materials could be used in the construction of habitats, vehicles, and even spacesuits, providing an additional layer of protection. Imagine houses and spacesuits built with these materials, protecting us from the harsh Martian environment. With the right technology and innovation, we can overcome the radiation problem and make Mars a new home for humanity. Section 7. Can we really do it? Terraforming Mars is a monumental task. It would require incredible technology, vast resources, and centuries of work. It's not something we can do overnight. The biggest challenge is probably cost. Transporting everything we need to Mars would be astronomically expensive. It would require a global effort with nations all over the world working together. There are also ethical concerns. Do we have the right to change another planet so dramatically? What if there's microbial life on Mars that we haven't discovered yet? We need to consider the consequences of our actions carefully. Section 8. Other ways to live on Mars. While we work towards terraforming, there are other ways to establish a human presence on Mars. These options might be more feasible in the near future. One option is to build domed cities. These would be sealed environments like giant greenhouses with breathable air, comfortable temperatures, and protection from radiation. We could also explore living in lava tubes. These underground tunnels, formed by ancient volcanoes, offer natural protection from radiation and meteoroids. These options wouldn't be as comfortable as a fully terraformed Mars, but they could provide a foothold for humans while we work on more ambitious plans. Section 9. A Martian Future. The idea of humans living on Mars might seem like science fiction, but it's a future we can work towards. Terraforming Mars is a long-term goal, a challenge for generations to come. Imagine a future where humans live on 2 planets. Mars could offer a second home for humanity, a safeguard against disasters on Earth. It could be a new frontier for exploration and discovery. The journey of 1,000 miles begins with a single step. By sending rovers, then astronauts, and eventually colonists, we can begin to build a future on Mars. It's a future worth striving for.